Right now, in Newport News, Virginia, 5,000 engineers and shipbuilders are in the middle of the most intense construction race in naval history. They're building the USS Enterprise, a $13 billion nuclear-powered aircraft carrier that's longer than the Chrysler Building is tall, and they're doing it under a deadline that most experts said was impossible. But here's what nobody tells you about building these floating cities. The real challenge isn't the size or the cost, it's that every single day of delay costs the Navy $2.5 million. And right now, they're already 18 months behind schedule. The pressure is insane. Engineers are working 12-hour shifts, 6 days a week. Welders are joining steel plates that weigh more than a school bus. And the entire operation is happening in a shipyard that's been building warships since 1886, using techniques that would make your head spin. Chapter 1. The only place on Earth. Here's something most people don't know. There's only one shipyard in the entire United States that can build nuclear aircraft carriers. One, Newport News. Shipbuilding in Virginia is the sole facility with the security clearances, the specialized equipment, and the skilled workforce to construct these monsters. This creates a problem. When you're the only game in town, you can't just scale up production like a car factory. You can't outsource parts to China. Every single component, from the nuclear reactors to the 30-ton anchors, has to be built, tested, and installed by workers who've spent decades mastering skills that barely exist anywhere else. The shipyard covers 550 acres. Inside, there are massive dry docks that can hold ships weighing over 100,000 tons. The main construction hall is so large it has its own weather system. Workers have reported seeing clouds form near the ceiling on humid days. But size isn't the issue. The issue is that Newport News is simultaneously building 2 Ford-class carriers, maintaining existing ships, and training the next generation of nuclear shipbuilders. It's like trying to build a skyscraper while living in it and teaching construction classes in the basement. Chapter 2. The Nuclear Secret. The heart of every aircraft carrier is its nuclear propulsion system. 2 A-1B reactors that will run for 50 years without refueling. These reactors are so powerful they could provide electricity for a city of 100,000 people. But here's where it gets crazy. The reactors are installed before the ship is even half built. Engineers have to lower these massive units into the hull using a 1,050-ton crane, positioning them with millimeter precision. If they're off by even a fraction of an inch, the entire power system could fail. The nuclear engineers working on these reactors go through years of specialized training. They need security clearances that take 18 months to obtain, and they're working with technology that's so classified they can't even tell their families what they did at work that day. One engineer I spoke with described the process. You're essentially building a power plant inside a ship that's going to get hit by waves, launched aircraft, and potentially enemy fire. Everything has to be overbuilt, redundant, and tested to destruction. We don't get second chances. The reactor compartment is sealed off from the rest of the ship by multiple bulkheads. The shielding alone weighs thousands of tons, and every weld, every pipe, every valve has to pass inspections that would make a NASA engineer nervous. Chapter 3. The Steel Mountain. The USS Enterprise will displace over 100,000 tons when complete. To put that in perspective, that's 200 million pounds of steel, aluminum, copper, and composite materials. The flight deck alone is 4.5 acres of reinforced steel that has to withstand the impact of 60,000-pound aircraft landing at 150 miles per hour. Building something this massive requires a construction technique called modular assembly. Instead of building the ship from the keel up like in the old days, Newport News constructs huge sections called superlifts that can weigh up to 900 tons each. These sections are built in different parts of the shipyard, then lifted by crane and welded together like massive Lego blocks. But here's the problem. Every superlift has to fit perfectly. We're talking about sections the size of apartment buildings that need to align within a quarter inch. If they don't, you can't just sand it down or add a shim. You have to cut apart thousands of welds and start over. The welders working on these joints are using a process called narrow gap welding that allows them to join steel plates up to 8 inches thick. The welds have to be X-rayed, ultrasound tested, and visually inspected. A single bad weld could compromise the structural integrity of the entire ship. One veteran welder told me, "I've been doing this for 30 years and I still get nervous every time I strike an arc on a critical joint." You're not just welding steel, you're welding something that 5,000 sailors are going to trust with their lives. Chapter 4. The Electromagnetic Revolution. The Ford-class carriers, including the Enterprise, are the first to use electromagnetic aircraft launch systems, or EMALS. This replaces the steam catapults that have been launching aircraft since World War II. The technology sounds simple. Use electromagnets to accelerate a 60,000-pound fighter jet from 0 to 170 miles per hour in 2 seconds. But making it work is a nightmare. The EMALS system requires massive amounts of electrical power delivered in precise bursts. The timing has to be perfect, or you'll either rip the landing gear off the aircraft or dump a $100 million fighter into the ocean. The system uses 60 million watts of power per launch. That's enough electricity to power 40,000 homes, delivered in less than 3 seconds. Engineers spent years developing the power storage systems, the control software, and the electromagnetic coils. Early tests were disasters. Catapults failed. Aircraft were damaged. The entire program was nearly cancelled. But they kept pushing. They redesigned the power systems. They rewrote millions of lines of code. They tested and retested until the system could launch aircraft more reliably than the old steam catapults. Now EMALS is working. But installing it in the Enterprise means threading thousands of feet of high-voltage cable through a ship that's still being built. It means coordinating with dozens of other systems. And it means training a new generation of sailors to maintain technology that didn't exist 5 years ago. Chapter 5. The Human Cost. Building an aircraft carrier isn't just an engineering challenge, it's a human endurance test. The workers at Newport News are putting in brutal hours. During peak construction periods, 12-hour shifts are standard. Some specialized crews work 14 or 16 hours when critical systems are being installed. They're working in confined spaces, extreme heat, and constant noise. The injury rate in shipbuilding is higher than almost any other industry. Workers are climbing scaffolding 100 feet above the ground. They're welding in tanks where the temperature hits 120 degrees. They're lifting heavy equipment in spaces so tight they can barely turn around. One safety manager described it. "We're asking people to do incredibly dangerous work with zero margin for error. A drop tool from the flight deck can kill someone 80 feet below. A bad weld can sink a ship. The pressure is constant, but the workers keep showing up. Many of them are 3rd or 4th generation shipbuilders. Their grandfathers built the carriers that fought in World War II. Their fathers built the Nimitz-class carriers. Now they're building the Ford class. There's a pride in this work that's hard to explain. These aren't just jobs. These are careers that define entire families. When a carrier launches, workers bring their children to watch. They point to specific sections and say, 'I built that.'" Chapter 6. The money problem. $13 billion is an almost incomprehensible amount of money. To put it in perspective, that's more than the GDP of 70 countries. It's enough to build 130 F-35 fighters. It's enough to fund NASA for an entire year. And the Enterprise is just one ship. The Navy plans to build 10 Ford-class carriers over the next 30 years. That's $130 billion, assuming costs don't increase, but they always increase. The first Ford-class carrier, the USS Gerald R. Ford, was supposed to cost $10.5 billion. Final cost, $13.3 billion. Every delay adds millions to the bill. When the Enterprise falls behind schedule, the Navy has to extend contracts, pay workers overtime, and keep expensive equipment sitting idle. The shipyard has to maintain facilities that aren't generating revenue. Suppliers have to store materials that aren't being used. Congress is watching every dollar. Defense critics argue that carriers are obsolete, vulnerable to hypersonic missiles and drone swarms. They say the money would be better spent on smaller, distributed forces. But the Navy disagrees. Carriers project power in ways no other platform can. They're mobile air bases that can operate anywhere in the world. They're diplomatic tools that can influence entire regions just by showing up. The debate rages on. But in Newport News, the work continues. Chapter 7. The technology nobody sees. Most people think of aircraft carriers as floating runways, but the real innovation is happening below decks in systems that will never make the news. The Enterprise will have the most advanced radar system ever installed on a ship. The dual-band radar can track thousands of targets simultaneously, from ballistic missiles to small boats. It can see threats over the horizon and coordinate defenses across an entire carrier strike group. The ship's internal network is essentially a floating data center. Miles of fiber optic cable connect thousands of computers, sensors, and weapon systems. The bandwidth is higher than most small cities, and all of it has to be protected from cyber attacks, electromagnetic pulses, and physical damage. The damage control systems are revolutionary. Sensors throughout the ship can detect fires, floods, and structural damage within seconds. Automated systems can seal compartments, reroute power, and activate suppression systems before human crews even know there's a problem. The medical facilities are equivalent to a Level 1 trauma center. The Enterprise will have operating rooms, intensive care units, and dental clinics. It can handle mass casualty events and perform complex surgeries in the middle of the ocean. All of this technology has to be installed while the ship is being built. Engineers are running cable through spaces that don't exist yet. They're mounting equipment on bulkheads that haven't been welded. They're testing systems that won't be powered up for months. It's organized chaos. And somehow, it works. Chapter 8. The Final Push. As the Enterprise nears completion, the pace becomes frantic. Systems that were installed years ago are finally being tested. Aircraft elevators are lifting loads for the first time. The nuclear reactors are approaching criticality. The ship is coming alive. But there are still thousands of tasks to complete. Every compartment has to be painted. Every piece of equipment has to be tested. Every system has to be certified. The Navy's acceptance trials are brutal, designed to find every flaw before the ship enters service. The workers know the end is near. They can see the finish line. But they also know that the final months are when mistakes happen. Fatigue sets in. Shortcuts become tempting. The pressure to meet deadlines can override safety protocols. Management is pushing hard to avoid the delays that plagued earlier Ford-class carriers. They're throwing resources at problem areas. They're working around the clock to resolve technical issues. They're doing everything possible to deliver the ship on time. Whether they succeed will determine the future of American naval power. It will influence defense budgets for decades. It will affect thousands of jobs and billions of dollars in contracts. But for the workers in Newport News, it's simpler than that. They're building the most powerful warship ever constructed. They're creating something that will serve for 50 years, that will project American power across the globe, that will be home to 5,000 sailors. They're building the USS Enterprise. And despite the impossible deadlines, the crushing pressure, and the insane complexity, they're going to finish it. Because that's what they do. That's what they've always done, and that's what they'll keep doing, one weld at a time until the job is complete. We are committed to releasing 3 videos a week. Like, share, subscribe, and hit the bell icon for more Anchor Watch.